Lovely, let's get started. Hi everyone, my name is Hans-Peter Bakker. I'm an applications engineer based in Cape Town in South Africa. It's lovely to have you all here. So basically we want to talk to you a little bit about 3DExperience. It has a lot of features and stuff, but today we're going to be kind of focusing on the simulations part of it. So it's very exciting, and let's get going. So today I want to talk about a few things. So the first thing I want to talk about is the power of cloud computing and what it can really do for you as a designer or anyone really, like an engineer or in any industry really, not necessarily engineering. But yeah, with the modern internet speeds and stuff like that, we have so much power at our fingertips and we can use it however we like. So first I want to talk about that, and then I'm going to talk a little bit about, very briefly, I'm going to just describe why simulation is a powerful tool for designers specifically. And then I'm going to go over two roles, so a simulation collaborator role and then a simulation engineer role. And then at the end, just as a kind of a fun thing that I find very interesting, I'm going to talk about generative design roles and what you can do with topology optimization and stuff like that. All right, so 3DExperience. 3DExperience is a cloud-based platform where you can do an array of things. And the benefit of the 3DExperience platform and the main focus of it is collaboration of different people, users, roles, activities. So you can basically do a lot of different things in one platform. And by a lot of different things, we'll get a little bit more into it. But so it's the same tool for everything. You have no files getting lost in transition or saving in weird places. You can do your designing, your tooling, your simulation, your PLM, all in one place. So let's see. So basically, it's very designer focused. So it has a designer-centric user experience. So you have complete control of your GUIs and how you set out your layout of your platform. It has just insane tools for designers. It's mostly super cloud-based. So that's a really, really big thing I want to talk about a lot, is how you can reduce costs by essentially having your computing be decentralized. So you don't have to have it on your expensive PC. You could have it somewhere else, or it's all based on the cloud. And for simulation specifically, there are so many benefits, but we'll get more into it later on. So it's very integrated. Every layer is integrated with every other layer inside the platform. So it's a great solution for CAD and PLM, but it's integrated, all of it. It's all integrated for whatever you might need. So also simulation. So multi-physics, it's got a very, it's got an approach to product performance optimization. It's very useful. And this is another feature that I will be talking a lot about, is the scalability of the platform. So across every level of design, you might need certain roles or power within the platform, and this gives you access to all of them whenever you may need them. So you could buy let's say you don't think you want too much complexity, so you buy a simple platform license, and then if you want more, you can always just upgrade whenever you like, or downgrade. It's just very scalable, and it has features for every level of design you may want to perform. It's very streamlined and productive, so it increases your automation capabilities within your design process, and it eliminates non-value added tasks. Great, just really great features. And here's another thing: the collaboration of the platform. So you can seamlessly interact with stakeholders inside and outside of your organization. So everyone on every level can integrate with each other through the platform. So let's talk a little bit about cloud computing. So cloud computing, it's decentralized computing, and it really is the future of computation. These days, with the internet speeds we have in most places in the world, you really don't need to invest in such intense hardware as you have in the past, where you can just offload it and you just have your PC to run, the displays and your actual interaction with 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 your computer and with what you need. So basically, it decentralizes everything, and it's really, really powerful and controllable. And you don't need to have all this like fancy hardware anymore, really. I just want to put a little poll on. Let's see. So I want to ask, how do you test your designs for strength and longevity? If you check in the poll, you should see a poll. So if you want to answer it, go ahead. Also, feel free to ask questions in the Q&A in the chat, and I'll respond to them. I'll check every now and then. Yeah, so let's carry on. So with hardware come many pitfalls and shortcomings. You could get power outages. We get them quite a lot here in South Africa, but I don't know where else. But it happens all the time with anyone. You need UPSs. Your power and cooling can always bug out and have issues. You need constant maintenance. Your security is, your own, and there's gonna viruses always happen, phishing attacks. You have disaster recovery queues, backing up of, for example, simulation jobs, staffing issues, licensing issues, depreciation of the actual physical, hardware and graphics cards and stuff. And then also insurance. These are all things that you don't really see on PCs. These are all hidden costs that you don't notice, but they are there. So with cloud computing, we can kind of reduce these and almost alleviate them because we do it for you. So with hardware, let's say you as a designer want to run a simulation on this part. You want to go from point A to point B, but the only option you have is a hardware option. So you have to run it through your computer. This isn't really a great choice because what happens is, your PC might not be strong enough or might not have enough RAM or computation power to actually run the simulation in, decent amount of time. It takes too long. Or you might have to run multiple analyses at the same time. Another feature to keep in mind is if you ever run a simulation, when you're running that simulation, you cannot do any other work. At least you can't design. So you'll sit there and stare at your screen as the thing just turns and turns. Where the truth is, you don't need to do that anymore. You can just offload it, and then that will become, that what you do is you just offload it. It's very easy and very straightforward, and then it happens on the cloud, and you just get a notification when it's done. Also, the licensing is very, very easy to manage, and it's very scalable as well. So we'll get there in the future. So let's say, once again, same scenario. You as a designer want to get from point A to point B. Let's try a different thing. So you could use the 3DExperience cloud simulation or cloud computation. It's not only simulation. It can do many, many different things. Let's talk a little bit about that. So let's say you have on-demand cloud computing 24/7 all the time. You don't have to. You can leave it overnight. You can leave it for a whole week. It's up to you. It has high-performance computing architecture. You have really, really next-generation CPUs on the cloud-based platform, and you have up to 144 true cores per analysis. So 144 cores really is a lot of cores. I have a pretty nice computer for simulation stuff, and it gives me, I think I can run with about 32 cores at max, and that's at max. So I would never really get that. So if you want more speedy analysis, you can do that. It gives you the option. Also, distributed computing, low latency networking, high performance and scalable system of storage. So you can always choose what you need. So you can always upgrade, you can always downgrade. That's the beauty of it. You don't have to make this big investment. And then maybe you buy a really fancy PC and then it doesn't actually get used for 5 years. You don't need to do that. You can always upgrade your license and then downgrade when you're finished, whatever you might need. Also, the results constantly save on the cloud, so you have less chance of loss of information from crashes. That's another thing to keep in mind. So your information is very secure. So this is something that I want to discuss quickly, is the included computation power within each role, right? So these are each roles. You have structural designer, structural engineer, performance engineer, mechanics engineer, durability performance engineer, all of these different roles, and they all build on each other, right? So the two most basic roles, structural designer and structural engineer, which are not basic, let me tell you, it's very, 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 very powerful stuff. They each have 4 cores that come with them as a basis. So So you can always run 4 cores. It's still not a bad amount of cores to run a cloud simulation on, and you can always upgrade. But then you have the more advanced roles like structural performance engineer, structural mechanics, which have 8 cores each. And then, fluid dynamics, you have 16 cores as a basis, which you get with the role. So yeah, but like I said many times, you can always go more if you need. So yeah. And that, obviously I mentioned already, when you're using cloud simulations, you can continue to design your tool or whatever you need on the side, because it happens externally. So the way the licensing works is very straightforward. So you have the embedded license, which is what we described. You can run 1 simulation at a time to a maximum of cores. It's suitable for typical routine use. So most people, for research, or if you want to experiment, or you just you don't need a mass amount of computation. The embedded license is fine, works great. That's all you would need. Then you can, if you want to have peak usage, you want to have all the computation power you can use tokens, which are reusable. So you would buy as many tokens as you would need, and you could distribute them among your designers. So you could have one designer have all the tokens and run a simulation very quickly, or you could, it depends on need and usage. So it really doesn't, because you're not running simulations 24/7 all the time, it doesn't make sense to have this hard, massive, really powerful PC that can do that. You could always just use when you need. It's amazing. So the tokens are great for, you can run a limited numbers of simulations at any given time, just need more tokens, I guess. And it's best for regular and high compute workloads. So it's very, very, very flexible. And then you get the credits, which are consumable. So you just buy them when you need. It's kind of a pay-as-you-go, pay-as-you-use type deal. So there's many different options for anyone. So whatever you might need, there's a solution with cloud computation. So that's what really is the core of why people love it so much, because of its variability and its adjustability. Okay, so quickly, I want to talk about the benefits of simulation for designers. It can lower your overall costs because you don't need to generate prototypes. You don't have issues with having to train someone for 20 years before they can actually run something. You could just run it straight away. It's very easy to learn. People pick it up very quickly. It's very intuitive, simulation in general. And you don't need large installations for the 3DExperience simulation stuff. It's very flexible. It's very scalable. There's a streamlined collaboration process. So every level is integrated, and it frees up hardware for other projects. It's just the beauty of it. So cloud simulation is great. Anyone who's used simulation knows how great it can be, and it really is just, it's gaining a lot of traction with designers and with engineers in general, because it has so much power, and you can take essentially shortcuts to your design because you have this insane tool that can run things for you. So it's just very fun stuff. Let's just check if we. I will reply to these questions. I see someone has, but I'll reply to them in a little bit. Let me just add another poll if you guys are interested. There we go. Cool. So cool. So that's the basis. I just talked a little bit about cloud, a little about simulation. Let's get into the meat. Let's get into the actual roles that we're talking about. So simulation collaborator is, it's essentially an answer to a problem. So let's say you, as a designer, run a simulation on a part, but you need a very expensive license to run that part. Let's assume that. Okay, so you do that. Then you have a stakeholder or project manager who wants to view that part, the simulation results of that part. Let's say you could just share it, but you could share screenshots, but it just really doesn't capture it very well. It's all, you do it and you share them a little feature of it. Like they only see a little picture. So this simulation collaborator solves that problem. What it is it's a relatively low cost alternative for people who don't actually need to run the simulations. So you run your simulations and you make an entire, you do an entire study. It takes weeks or months or days or whatever you want. And then you can share it with your project manager or with anyone who has this role, and they can open it, view it, make plots. They can share it. They can compare with different the pros and cons of different designs. They can view it and make section views, and they can fully review that simulation without actually needing the tool. So it really is an answer to a problem that a lot of designs actually run into. So the simulation collaborator role. It is a very, very powerful simulation tool. It can connect people all over the world. It can connect designers, project managers, engineers, like requirements managers, durability engineers. Everyone gets connected into one centralized hub that allows them to share every single level of their PLM system. So they can project. So essentially, they can the actual, like, you don't have to have everyone having a really expensive role, because why? You don't need that. You could have one person have the role that's really, really, the more powerful role, and they can share it whatever they need, and that person can use it however they would need. So it really is it's like a hub where all simulation can kind of flow around it, and everyone who needs to interact with that simulation can in their specific way. So you see this is like a comparison between different simulation results that you can get from just the role. So it really is, it's a simplification of simulations. It doesn't need to be so complicated. It can be much more simple. And you can see here, this is like a bracket comparison. So you have many brackets, and you can actually like evaluate the scores of each one, masses, stresses, displacements of body parts, or whatever you might need. But yeah, it is essentially it's a seamless integration between simulation processes and simulators, people who might need it, and it connects everyone. That's the beauty of it. So it's kind of like a constant sharing, collaborative space where everyone can comment and add things and share it, and show exactly why they chose that part or anything like that. So it's a very it's an open process. Everyone sees what's going on the entire process. This is a performance trade-off, which is one of the roles. You can make comments on it. It's it takes away a lot of the confusion and the confusion of simulation, because everyone can see the whole process. So yeah, let's go on. Yeah, so simulation collaborator, it can accelerate the selection of the best designs by comparing performance metrics across alternatives and ranking those designs based on requirements using multi-criteria decision-making methods. So basically, it can compare performances of different configurations, and you don't need the structural engineering or structural design or more advanced roles. It just lets you view whatever you might need and make cuts and changes and stuff on the actual simulation result. And it's perfect for project managers, head engineers, whoever might need it. You can perform trade-offs between competing objectives and constraints. So let me just show. So this performance trade-off role is that one that we actually saw, and it lets you have multiple simulation configurations, and you can perform trade-offs and on all of them, and why you would want them, why you would need them. It lets you review, share, and collaborate on geometry and on your simulation results from anywhere through a lightweight browser-based widget. So it's completely browser-based. So you could run it on your phone, your tablet, your little PC or your Mac, or whatever you want. So you can run it on many different things, and you can get those results from anywhere as long as you have internet connection. So you don't need to be on the ground to actually get all the results you need. Yeah, really, really awesome. You can also have complete control of your dashboard. You can decide how you want to set it up. You can add widgets to it in any configuration you like. And yeah, it's just a really, really, really powerful tool for many, many, many levels of people to collaborate from all over the world. So yeah, that simulation collaborator, it's very exciting. It's fun stuff. But let's go to the structural engineer. This is the real simulation role that your designer would have, that would integrate with the collaborative role. Let's just see how questions are doing. I see earphones answering. Brilliant. Okay, I'm gonna go on then. So yeah, this is a structural engineer. It's one of the roles in 3DExperience platform area, and you get these. These are this is the role, simulation engineer, and then you get or structural engineer. My apologies. And within the role, you get a bunch of apps. Each app has a different purpose and does different things. The structural model creation, we'll get into a bit more, is super powerful, insanely powerful. Then the physics results explorer, also incredibly powerful, like really, really cool stuff. Yeah, so let's go on to the actual meat of it. But first, I just want to explain a bit where structural engineer fits in with all the other roles in the platform. So this is the simulation portfolio within the platform. So you have structural designer, which is the most basic role. And then you have structural engineer, structural performance engineer, durability performance engineer, and then you have these durability mechanics engineer roles above them. But what I want you to understand is that each layer builds upon the previous one. So you have structural designer, and then you have structural engineer, which includes the structural designer roles, and so on. So structural designer has linear static, it has frequency analysis, it has thermal, buckling, cloud computing, which is, I mean, they all obviously is one of the cornerstones of the 3DExperience platform, so it's included. And then it has this assistant, which is a really, really, really nice way of laying out your simulations and setting them out, because everyone who's done sims knows how difficult that can actually be sometimes. And then you have a structural engineer role, which has those roles that we talked about, plus these additional ones. It has harmonic responses, it has model dynamic responses, it has advanced meshing, it has advanced elements to mesh with, it has multi-step simulation studies, it has advanced post-processing. So yeah, all of these really, really powerful stuff. And you can do most of what you need with this, but keep in mind, insanely scalable. So you could have this role, and then if you run into a project where you would need a more advanced one, you can always upgrade for the time of the project and then downgrade afterwards. It's completely up to you. It can essentially just fit whatever role you might need it to. That's what makes the cloud computing variability so great. Yeah, so it's also, yeah, it's one step up from this one. So these are just a couple fun little things that the 3DExperience platform can do. Not all of these are included in the structural engineer role, but I mean, like I said, if you need them, you can always upgrade to them. But you can do engine thermal design, you can do large displacement analysis, you can do exhaust systems, you can do HVAC cabin comfort analysis, which is great. It's awesome. It can essentially simulate like the human environment and what would be comfortable for a human being. So it can simulate like the humidity, the temperature, the airflow, the saturation of the air, and just essentially tell you how comfortable these people would be in the scenario. So for any industry, it's great. Then you have electronic cooling modules, elastic modeling of parts. You can see the flexibility of these. It has cycle testing, free surface of motion. So a bunch of fluid simulation type roles, as well as structural and like many more. So it also has these are advanced applications. So the other ones were mainstream. These are more advanced. So you have crash tests. You can see how accurate this is. You can simulate an airplane landing on a cruiser and the air coming off of it. You could do the same with like a car overtaking a truck or anything like that. You can do advanced braking tests. You can do offshore wind turbine tests. You can actually simulate the fluid of the ocean, and as it moves like this. You can measure, you can simulate hydroplaning, you can simulate collision testing, you can simulate sprinkler nozzles. Oh, it's cool, it's great. It gets me very excited. As well as you can also do electromagnetic simulations. You can do plastic simulations. And another thing to keep in mind is the 3DExperience platform uses industry-leading abacus solvers. So the results that you get, you can be pretty confident are accurate. Let me just see how we're doing. Looks good. Cool. I hope you guys are having a good time. I am. Cool. So this is the structural engineer role. A little bit more about it. So it is it's incredibly powerful simulation tool. It can do every step of your simulation that you might need. It can do every level, every gradient. Obviously, it's all like it can be done from anywhere. It can be done, if you could take your computer, you could go do it somewhere far away, and like as long as you have internet, it's fine. It can do structural and thermal types. So the structural engineer role is essentially one step up from the basic simulation role included in 3DX, which is the structural designer. So it can do, most of what you would need in your day-to-day design, plus a whole lot more, right? It can save you a lot of costs. It can save a lot of simulation costs, and so this is just a plot. You can see how easily it does that. This is just a simulation of a fan, but so you can. It also integrates with many of the mainstream design products, I guess. Like for example, SolidWorks. It integrates very well. So there's a lot of integration between the two, but we'll show you that in a little demonstration in a second. The meshing is insanely powerful. It gets me very excited to think about, because each part can be meshed independently. You have a bunch of different types of meshes that you can use. It has super advanced solvers that you can run with. So you could do biomedical is actually a large industry that is that uses this product quite a lot as well. So you can check the static put, the actual deviation of the body and how it changes. So you can save a lot of costs. You can do this is kind of the GUI of the actual platform. So each of these is a little window that you can move. You can change it and shift them around, and you can make them bigger and smaller and add new widgets and stuff. It has a great deal of variability and flexibility, which suits most people and can help with most of your problems. So it's wow, very exciting stuff. The structural engineer role will hit most of what you might need it to, and what you would need is advanced simulations, right? And that's what it does. Take into account, it also has cloud-based designs and cloud-based simulations, and you can offload all your sims super easily to a cloud solver. So very cool, very exciting. So structural simulations, it has clean interfaces, it has easy workflows, there are basic simulation options within it. This is the assistant, which I talked about earlier. It helps you set out exactly what you're doing and helps you kind of keep track of what you've done in your sim to ensure accuracy. It has a guided model, the assistant built up. It has automatic meshing, which it's like industry leading meshing, this stuff. You can run a mesh and it can automatically mesh the whole part or assembly, and then you can edit each single feature if you like. Also, the visualizations of the results are amazing. You can essentially see whatever you need to. So structural simulation with SolidWorks. Let's look at this. So we have this complex assembly inside SolidWorks, and we want to use it for a design. We want to run a simulation on it. Before I start that, let me just check. It looks good. Okay. So we want to run a simulation on this bracket. So let's go ahead. So the first thing you do, this is the 3DExperience. This is SolidWorks, sorry, and this is a really useful little 3DExperience widget that you can not a widget, it's a little download, but it adds on SolidWorks, and then you can essentially combine all the features. So essentially, it has a built-in PLM system of SolidWorks files. So what they're doing now is you save all the parts into 3DExperience. It gets converted into a 3DExperience body, and then in 3DExperience you can, through the SolidWorks add-in, you can launch and do simulations based on that part. So you save it in, you rename it, whatever you might like. It has a lot of variability, and then you call it whatever. Many different types of simulations are possible through Structural Engineer. So we insert the part. So we insert the part, and then let's go on. So the first thing we did is we opened SolidWorks. We had the parts in. We uploaded it to 3DExperience. We open it, and then we open it in 3DExperience client, which is it has a small native install, but it's not really a big deal. I think most of your actual computations can be done off your PC. So the next thing I want to do is I want to create and run a sim. So this is how we do it. You open the pod and you can see the assistant there on the right, tells you every step. Every time you press in the pod, it tells you all the other bodies below it. So it tells you exactly, it shows you how to use it. So let's say we want to apply material, you go to the material palette, there's hundreds of materials and they're more added all the time. Another thing to keep in mind is the usefulness of having everything always up to date. That's an insane, the licensing of the 3DExperience is world class. So you can pick materials, you can select different ones, cool, choose them. It lets you have real control of your materials and make sure all your parts within your assembly are accurate. And also the contacts within 3DX are industry leading, insanely powerful stuff. I don't know if anyone's ever I've used SOLIDWORKS simulation quite a lot, and I find the contacts are great, but they also, sometimes it's, at least 3DExperience, it like builds on the already amazing SOLIDWORKS portfolio with having automatic contacts, which are far more advanced than pretty much any native design tool that you might use. So you can go, they've now fixed the 3 little holes, and they're adding a force to the actual ball. And then now we can run it on, you can run it however you like. So first thing we do, we can mesh, and you can see there are 3 different parts in the assembly, each one meshed automatically. And then what you can do is you can go and you can change the mesh sizing and controls and type of each single assembly, each part within the assembly. So we've refined the mesh on the actual bracket, and now we run the simulation. So you press simulation, and then you can go to cloud, and you can choose the number of cores that you want to actually run with. It depends on you, whatever you might need. So we run the sim. Cool. So we've taken the body into the 3DExperience platform from SOLIDWORKS. We've set up the study and we've run it. The default study location is in your actual. It actually will run automatically on your PC, but you can select cloud. It's great. It's very easy, and obviously this is using the built-in 4 cores that come with the 3DExperience platform role. So we run the simulation, cool, we say close, and this is our results. This is our result visualizer, okay? You can make any type of plot that you can imagine with this. It just takes a little bit of setup. So the first thing we do is we change the scale. So we make it more, more realistic for what the actual result would be. So we can animate the body very easily just by looking at pressing that little play button on the left. It's really cool. You can add displacements. You can check, you see in that little drop down how many actual plots there are. Like how you can make all of these insanely powerful stuff. So this is really cool. It's a compression tension plot. The red parts are tension and the blue parts are compression, and you can see by how much. So you can see exactly the forces on a body and adjust them. And keep in mind, this entire simulation was run it wasn't run natively, it was run on the cloud. Oh, it's awesome. It's great stuff. So you can make section plots, you can see into the parts and see exactly where your stresses are acting. You can change them, you can adjust it, you can change the size of all the deformations. Great stuff. Also, if you hide a body, you can see inside all the other bodies, and you can see the actual effects of this body on here. You can change, essentially you're changing the subject of the study. Okay, let me just check the, okay, cool. Lovely. So now what I want to do, so what we've done is we've taken the part from SOLIDWORKS, saved it into the 3DExperience platform. Then we run a simulation on the cloud. Now what we do is, let's see a little bit more of that integration with SOLIDWORKS. So what we do is we take the body and we just this is the 3DExperience platform, easily just drag it in, opens it to SOLIDWORKS, exactly in the original part. And then we want to make a change. So we go to the part, and this is really cool. This is the PLM system built into SOLIDWORKS. So you reserve the part, the whole assembly, so now you can make changes, and it can actually keep the changes instead of being read-only. So you go and you make a cut in the part or whatever you might do. It depends on you. And then you would go back and you would save all the parts. So it updates the original files with the new ones. So you've essentially, the revision control of the PLM system is great. So you're cool, it's done, it's been re-uploaded. So now if you go to the actual simulation that you ran and you show the body, you do a refresh and it'll bring up that cut in the bracket. So you'll see, you say, yeah, it has a little cut, cool, now the part's changed. So what happens to our simulation? If you go to the results file, it tells you results are out of date. You have to rerun it. So you go back to simulate and you just keep the things the same because it doesn't change. You can either keep or overwrite the previous results. You say, okay, and you run. And then it reruns the simulation and upgrades your results. So what I want to show you as well is, so this is the 3DExperience kind of dashboard. It's a 3D space thing. So this is actually where this essentially runs on this system of collaborative spaces, which is like a system of, I guess it's like data-driven file storage. It's kind of revolutionary. And then, so basically you have the main parts, and then here's your actual simulation. So let's say right now, this is what you're looking at while your simulation is running. When it finishes, you'll get a notification up here, like a little one will pop down here, and it will tell you the simulation is completed. And then you can go into it, you can just press it, or you take this simulation and you drag it into the 3D Play environment, and you check it out, and you can view it and make cuts and stuff there. So what I want to just remind you of is linear. The structural engineer role has linear results, and these advanced roles have non-linear. But keep in mind the scalability. You can always upgrade. You can always upgrade from one to the next if you choose. Let me just see how we're doing there. Great. So this is a little bit of information about the structural model creation role. This little one you see over here. It's a way of creating your mesh, your FEM models, and bringing your body in, changing your body as you like. So what you can do is you can apply materials, you can define sections inside the assembly or the part for FEM analysis. You can create virtual or real built pre-tensioned sections. You can define connections. You can mark parts as rigid bodies. All of these features that you can do. Also, these are different FEM models that you can do. You can use very, very advanced, industry-leading stuff. Also, what to keep in mind is the way the FEM is actually run in this analysis is great. You have like an original part, and then you can take it in and you create a FEM model of it, and then that model becomes almost its own part. And that part you can make 10 FEM models, and you can use them all if you want. So it's very modular. When you run a sim, you can choose which FEM model. So you could have 10 different levels of mesh refinement on the body, and then you could decide, okay, I want to use the most coarse or the most fine or whatever you like for a given simulation. You can make many FEM models, and it's really, really nice way of controlling it. Also the contacts are automatic, hassle-free, industry-leading stuff, very powerful. Okay, also the meshing, it's great. It's very exciting. So you can create a mesh of assemblies or an assembly of meshes. So you could just mesh one part, and then let's say you have like an airplane with a bunch of struts in the airplane, you could mesh the one strut and then take that mesh and use that mesh FEM model and apply it through the whole body, the whole assembly. So you could take one FEM FEM model of a part, and use it many times, or you can just mesh the whole assembly, like we saw in the example. It uses rule-based meshing, multiple meshing techniques. You can make an octree tet meshing, tetrahedron meshing, sweep hex meshing, partition-based hex mesher. All of these different mesh body methods, which can suit you in your industry as you choose. So great stuff, very powerful. This is a tetrahedral mesh. You can change, or you have a great deal of control of how you actually want your body to mesh. The parameter control, so very, very exciting. Also, the physics result explorer. Each of these is a different plot you can actually generate within the body, within this role, the physics results explorer role. It's high performance visualization, great stuff. built to handle large data sets, state-of-the-art rendering, like this one over here, to actually render the actual body with even a display on the screen. That's great. Various 3D plot types, contours, isosurfaces, symbol plots. You can make animations, which we saw, result sensors. Yeah, so you can pretty much display whatever you choose of your result. It'll probably be everything, but that's what makes it so great. Okay, so quickly, summary of the body, summary of what we've seen. We've seen that the structural engineer can provide new possibilities for structural analysis and durability. It's powered by Abacus solver, and it's very cyber secure. It's associated to SOLIDWORKS, which makes it very streamlined if you have the SOLIDWORKS ready. So you can see it as an add-in. You could replace many functions of your design tool with 3DExperience. It's completely up to you. It's got sophisticated equation solvers. It can analyze challenging nonlinear problems. It has options to work with advanced methods. You can run more complex analysis, reduced runtime, less failed runs. You can use included cloud computing to further decrease runtime as well. Also, you'll never drop. If you do drop your license, your results are still accessible to you. That's another feature that's really great. And one thing to keep in mind is 3DExperience isn't a bunch of silos. It's not a bunch of pillars that each independently work on their own. It's one platform. Everything is integrated. You can do, essentially, this is an integrated simulation tool. So your licenses are managed by a username. You have cloud computation variability. Also, all data is backed up. So it's essentially a PLM simulation tool. So you can control the entire lifetime or lifespan of some design project. Are there any questions on this kind of stuff? I don't see any. That's great. That's okay. Let me know if you have anything you'd like to ask. I can try and answer it. Okay, let's go on. So we have a little bit of time left. I quickly want to chat to you about something that I find very exciting, is the function-driven generative designer role. This isn't included in the structural engineer role, but it's just one of the many little packages that you can include in your 3DExperience if you decide to. It's incredibly powerful. So with the rise of 3D printing in industry, this role can help automate and reduce weight on many things. So it's essentially topology optimization. So it's one of the roles. Let's say you have this traditional bracket design over here, and you want to reduce weight. You can do it very easily through different methods. So these are all generated through, like, for example, the topology optimization might do this one, and you can just create this one or this one. So it's just really powerful for computer-aided design. So you could just quickly run a design study on a part and just see if you like it, how you would change it, what you can cut off, what you don't need. Awesome stuff. So essentially, it's a really great method for still meeting your KPIs while reducing, weight and material costs. Really, really great stuff. So imagine you have a legacy part. This is the original part, and then you generate these two parts. So it has options. You can create additive manufacture, 3D print part, or you can create a milled part, because not everyone has a really expensive titanium printer. So this is just a little description of it. Let's say you have a bracket on a car, for example, this thing that you want to save weight on, or you don't need to have so much material. You can essentially simulate the connection to the brackets around it, and also how it would be loaded. So you create these little, what are they called again? Functional, I think it says now, functional regions. Anyways, so let's say you want to save 25% of space or weight or whatever you choose. You can decide beforehand, and then it creates it for you, and it's very easy. What you do then is you can validate the shape, and it runs a little study on it to see if the part could withstand the force that you expect it to. And then you go through detailed design, and you just cut away the sections that aren't necessary. You make these little cuts, and then you can just very easily smooth them out, because you don't want to have a really rough little part in your final design. So then you get this beautiful looking thing that is really light and is still meeting your KPIs. And then you can, it works perfectly, and you can either 3D print it, and this is also the thing, you can also mill it. But you see there, you save 50% of your weight. It's great stuff. Also, with this roll, because it's so powerful, you have, it's not just the part, it's also, you can also do an entire assembly topology optimizations. So yeah, just a little taste of the capability that you have in this platform. It can do the most basic up to the most complex of what you might need it to. Yeah. So there's something I want to quickly talk about. If you have any questions, please let me know. But I want to put. Where is it now? Yeah. So we are. Let's do this. Yeah. So I've created a poll there about coming to a hands-on event. So this is in South Africa. So if you're not there, sorry, but hopefully one day we can include you somehow. I have a. What is this thing? Yeah, so this is we're doing a hands-on test drive. We pretty much bring people in with the platform. We show them how to use it and how it can work. So there's one in Cape Town and Durban. If you want to please scan this, it will take you to a link where you can register. And then there's one in Centurion as well where you can also register. Please scan these if you like. I see some people are saying yes. That's awesome. I really hope to see you. And I'm based in Cape Town, so if you're near, please come, and I can show you why I'm so excited about this and why it's such a industry-leading feature. Yeah, so I see there in the chat everyone saying the idea behind the hands-on is for you guys to get time with the software, to play with it, ask questions, get a better understanding. We want you to get used to it, to play with it and stuff like that. So if we can help you with that, then we will. So yeah, we're also running a deal on these roles, and I want to share that with you. Wait with that. I created beforehand.
Yeah. Deal.
Yeah.
Can you hear me?
Yeah.
Okay. So the deal is sort of a bundle, and it's part of what Hans has shown you guys today, where you would essentially get everything shown at a cost lower than even the single license. You get access to the PLM system, the collaboration features, and so forth, but the total cost of that is even lower than the just getting the simulation license itself. So I'd encourage you guys, if you're interested in this or anything Hans has spoken about today, to just pop us a mail either through the sales or support email, or maybe even put it there in the chat, and then we can go from there and engage with you guys individually on that option.
Yeah, that'd be great. Cool. Before I go, are there any more questions? Does anyone have anything else they want to ask? Okay. Thank you so much, everyone. I appreciate it. Please reach out to us at we work at MeCAD. If you can follow these links, and you can please contact us. We'd love to get in contact with you guys and show you more about the platform, because there's so much more. I couldn't actually squeeze it all into the time I had, but next time. Yeah. So let me just say goodbye now. Goodbye, everyone. Thank you so much for coming. Appreciate it. And have a great day, or wherever you are, night, I guess.